Good day, everyone. Today, our topic is engineering integrity and morality, focusing on a recent case of infrastructure corruption in the Philippines. As future engineers, it's important to understand that integrity and morality are the foundations of our profession. When these values are ignored, corruption can occur, leading to unsafe structures, wasted public funds, and loss of public trust. Through this case study, we aim to examine how ethical lapses happen, their impact on society, and what measures can be taken to uphold honesty and accountability in engineering practice. Why engineering and integrity and morality matters. Engineering integrity is the foundation of public trust and safety. Every structure, system, or project we build affects lives, from roads and bridges to flood control systems. When engineers act with honesty and moral responsibility, they ensure that designs are safe, funds are used properly, and the public's welfare is prioritized. However, when integrity is compromised, the consequences can be devastating. Unsafe infrastructure, wasted resources, and even loss of lives. That's why integrity is not just a personal value, but a professional duty that defines the true purpose of engineering: to serve humanity responsibly. For our case study, we focus on a recent corruption issue involving flood control infrastructure projects in the Philippines. According to Commission on Audit, reports, and several news investigations, millions of pesos were allegedly lost due to overpricing, ghost projects, and substandard construction materials. These projects, meant to protect communities from flooding, were compromised because of bribery, falsified documents, and collusion between contractors and some public officials. As a result, flood control system failed to function properly during heavy rains, worsening the effects of floods in several areas. This case clearly shows how the absence of engineering integrity can lead not only to corruption but also to the suffering of the public that these projects were supposed to protect. The consequences of engineering corruption extend far beyond financial loss. Technically, poorly designed or substandard flood control structures fail to perform their purpose, causing more severe flooding and structural damage. Socially, communities lost trust in both engineers and the government, while lives and properties are placed at greater risk. Economically, the government wastes millions of pesos that could have funded effective infrastructure or social programs. Businesses and livelihoods are also disrupted whenever flooding occurs. These impacts remind us that corruption in engineering is never a victimless act. It directly affects the safety, stability, and welfare of the people. Corruption in engineering projects often happens because of a combination of weak systems and human behavior. One root cause is the lack of transparency and accountability in project implementation, such as unclear auditing, fake bidding, or poor monitoring of construction quality. Some officials and contractors may take advantage of these gaps for personal gain. There's also the issue of moral complacency, when professionals prioritize profit or political pressure over ethical responsibility. Enabling mechanisms like poor enforcement of anti-corruption laws, weak whistleblower protection, and limited public awareness make it easier for corruption to continue unchecked. Addressing these root causes requires both institutional reform and personal moral commitment among engineers and leaders. Preventing engineering corruption requires a multi-level approach. Technically, projects must use transparent digital systems for monitoring budgets, materials, and progress, ensuring that every step is traceable and verified. Institutionally, engineering offices and agencies should promote strict ethical codes, regular audits, and whistleblower protections to hold individuals accountable. Legally, stronger enforcement of anti-graft laws and penalties for both public officials and contractors must be ensured. Lastly, civic participation is vital. Communities, media, and civil organizations should encourage to monitor infrastructure projects and demand transparency. When all these sectors work together, corruption becomes harder to hide, and integrity becomes the norm in engineering practice. Social justice plays a vital role in addressing the harm caused by engineering corruption. When projects fail due to dishonesty or negligence, affected communities deserve remedies such as proper compensation, reconstruction, and transparent investigations. Restitution must also be pursued, meaning that those responsible for corruption should return misused funds and face appropriate legal action. Beyond punishment, there should be efforts for community recovery, ensuring that damaged infrastructure is rebuilt correctly and that public trust is restored. True justice is not only about holding wrongdoers accountable, but also about healing communities and rebuilding systems that protect people's rights and safety. To strengthen integrity in engineering practice, several key recommendations can be made. For engineers, continuous ethics education and strict adherence to professional codes should be emphasized. Engineers must always prioritize public safety over personal or political interests. For institutions, transparency systems such as open contracting, third-party audits, and digital monitoring should be mandatory to prevent manipulation of projects. Meanwhile, for policymakers, reforms must focus on enforcing accountability, protecting whistleblowers, and ensuring fair procurement processes. Collaboration among these three sectors, engineers, institutions, and policymakers, is essential in building a culture of honesty, responsibility, and moral leadership within the engineering profession. To make these recommendations effective, a clear implementation roadmap is needed. This begins with setting short-term actions like conducting ethics seminars, establishing transparency portals, and forming audit teams for public works. In the midterm, institutions should integrate digital tracking systems for project monitoring and strengthen coordination between government agencies, engineers, and communities. For the long term, continuous policy evaluation and independent oversight bodies must ensure sustained ethical practices. Measurable indicators, such as reduced audit violations, timely completion of projects, and increased public satisfaction, can be used to track progress. Through this roadmap, we can transform engineering ethics from a mere ideal into a consistent and measurable practice. This presentation is supported by credible sources, such as Commission on Audit or COA, Department of Public Works and Highways or DPWH, and major Philippine news outlets like Philippine Daily Inquirer, Rappler, and ABS-CBN News. These reports expose irregularities in several flood control projects, including fund misuse, overpricing, and incomplete or substandard construction. Using these references ensures that our analysis is based on verified evidence and not just opinion. It also highlights how transparency and investigative journalism play an important role in uncovering corruption and promoting accountability within engineering institutions. In the end, engineering is more than just building structures. It's about building trust, safety, and integrity. The fight against corruption begins with every engineer's moral choice to do what is right, even when no one is watching. By upholding honesty and accountability, we not only create stronger infrastructures, but also a stronger nation. This has been my report. Good day and goodbye.